Welcome friends, welcome to JCE Connect. Today we are going to solve few problems on aerial photogrammetry. Problem number 1. A vertical photograph was taken at an altitude of 1200 meters above mean sea level. Determine the scale of photograph for a terrain lying at an elevation of 80 meters and 300 meters if the focal length of camera is 15 centimeter. Now if you totally observe the problem, what it says is that, see, they have given the height of exposure station from the datum. I'll show you what will be that. Now if you take a datum, this is datum, this is a ground, and you'll be having a photograph here, and then you'll be having a camera point O. Now this height from exposure station O to the datum, that we called as what? This is capital H, and the ground elevation from the datum, that we called as what? Small h. So these things they have given. So two different locations they have given. One is when the elevation is of 80 meters, ground elevation is of 80 meters, and when the ground elevation is of 300 meters. And along with that they have given the focal length of 15 centimeter. Now your intention is to determine the scale. Now we'll solve this problem. If you see, now required formula for that is, see, SH. SH means the scale for the particular height, that equals to F divided by capital H minus small h. Now this is the formula. Now by using that formula we are going to derive the, or we are going to get the scale for the two different elevations, that is for 80 meter and one for 300 meter. Step number 1, that is h is equal to 80 meter. Now by using the same formula, that is S80, for this elevation 80, you are going to determine the scale. That is, see, there is a difference between the scale and that is representative factor. When you will be having a scale, you should have a different unit. Now see that whatever this focal length will be there, that unit you have to take, and the remaining whatever the units will be of that particular dimension will be there, that's same unit you are going to take there. Means here it is 15 centimeter I have taken, and below that, see, it is 1200 minus 80 meters. So right, this is 15 centimeter, this is 1200 minus 80 meter. So it is going to be 1 centimeter divided by 74.67 meters. This is the scale. It means that 1 centimeter is to 74.67 is the scale. Now this 1 centimeter will be there on the photograph. This 1 centimeter equals to 74.67 meters on the ground. This is the scale, that is map to the ground, right? Map to the ground, map distance to the ground distance. So it is 1 centimeter is on the photograph, which is equal to the on the ground, it is 74.67 meters. Now representative factor, how we represent that in terms of 1:2, see, that is you are going to take the same units. Means the whatever unit you will be using here, you should have the same unit at the denominator also. So it is 15, you have to convert it to the meters, that is 15 divided by 100 divided by 1200 minus 80, that also be in the meters. So it is going to be 1:70, that is 1:7467. Now this is the representative factor. So there is a difference between representative factor and scale. What is the difference? Means that we are going to deal with the same units. We will be having the same units at the top, also at the bottom. But for the scale, you should represent what you are having the dimension on the map and what you are having the dimension on the ground. So this is what the first step. So here you will be having a scale of 1:74.67 meters. Means 1 centimeter is equal to 74.67 meters, and representative factor is 1:7467. Now if you are coming to the step 2, where you will be having a height of 300 meter, then yes, 300 is equal to focal length is 15 centimeter, capital H minus divided by small h, that is capital H minus small h, that is 1200 minus 300. So it is going to be 15 centimeter divided by 900 meters. Now that equals to 1 centimeter on the map equals to 60 meter on the ground. Means 1 centimeter on the photograph and that equals to 60 meter on the ground. So this is what 1 centimeter is to 60 meter. 1 centimeter on the ground 1 centimeter on the photograph and 60 meters on the ground. The same representative factor will be here, that is you are going to convert this 15 centimeter into the meter and the denominator will be in the meters. So it is going to be 1:6000. This is the representative factor. Here you will be having the same units, 1:6000, but here see that it shows in scale, it shows whatever scale you will be having on the photograph, that 1 centimeter on the photograph, it is going to be measure 60 meter on the ground. That you have to keep in mind. So this is the problem where we are going to get the scale for different elevations. Now my friends, we are going to solve second problem, and I'll read that problem. A camera having a focal length of 20 centimeter is used to take a vertical photograph to a terrain having an average elevation of 1500 meters. What is the height above sea level at which an aircraft must fly in order to get the scale of 1:8000? Now here in this problem, if you analyze the problem, what it says is that they have given the focal length and they have given the small h, average elevation of a ground, that is 1500 meters. Along with that they have given the scale, that is scale 1:8000. Now see this 1:8000. Now this is the representative factor. If they might have given the regular scale, it may be 1 centimeter is to something on the ground, but they have given what they have given here is a representative factor. Now if you see this is 1:8000, right? So three things you have to keep in mind. One, they have given the focal length, that is 20 centimeter, and then they have given the 1500 meters small h, that is ground elevation. Then they have given the representative factor 1:8000. So you can easily understand the difference between this scale and the representative factor. Even though it has mentioned that to get the scale of 1:8000 means this is a representative factor, means scale can be represented in that manner also, right? So we'll go for that. Now your average, your intention is to find what they have said, that you are going to find out the height of aircraft. Now that camera is attached to that aircraft, right? So you are going to find out the capital H, means the height of the camera above the datum, right? So you are going to find out the capital H. Now see, this is the datum. You will be having a ground with the elevation, then you will be having a aircraft, right? So aircraft, I'll try to draw that aircraft in a best possible way. This is the aircraft and it is going to have a camera here. Now this height, now see this height you are supposed to find out, right? This is capital H and this is small h, right? So you are going to find out the capital H. Now how to get that? They have given the representative factor and you are supposed to determine the R. Now the formula required for that is R is equal to F divided by capital H minus small h. Now here, if you are getting the scale, if scale means the F will be in the centimeter and the denominator will be in the meters, but here you will be having the representative factor, it means that F should be also in meter and the denominator should be also in the meter, right? So here, now see that what are the things they have given. R is given, that is 1:8000, that is representative factor. Small h is given, that is 1500 meter terrain average elevation, and then you are supposed to determine capital H. Now it is very easy. Now see this is R is equal to F divided by capital H minus small h. Now this R 1:8000. F, see, you are going to convert that in terms of meter as this is a representative factor. So I have converted that 20 divided by 100 divided by h. I don't know capital H, so I'll be keeping that as it is, minus 1500 meters. Now it is going to be, see that I'll take this term here, right, this side. So it is going to be, see, h minus 1500, that equals to 20 divided by 100 into 8000. Now this is h minus 1500, that equals to 1600. Now h is equal to 1600 plus, if this 1500 comes this side, it is going to be 1600 plus 1500, that is going to be 3100, means 3100 meters above the mean sea level. 3100, right? So 3100 meters above the mean sea level. This is your h. Now this is problem number 2. Now we're going for the next problem. Okay friends, now this is the problem number 3, that and it says that a line AB 2000 meters long, laying at an elevation of 500 meters, this is ground RL 500 meters, measures 8.65 centimeters on a vertical photograph, for which the focal length is 20 centimeter. Determine the scale of photograph in an area the average elevation of which is about 800 meters. Now you have to understand this problem. What they have said is there, now on the ground, say you will be having a ground. I'll try to draw that here. This is the ground, and on this ground you will be having 2 points A and B, and this distance is about 2000 meters. Now this is A and B, about 2000 meters. The same on the photograph here, small a and b on the photograph, it is 8.65 centimeters, right? And then you will be having this camera. Now this has been done, right? This has been done. The ground elevation is also given. See, you will be having a datum, and this small h here, this is it is 500 meters, right? Small h is 500 meters. Now this AB, which is 2000 on the ground, it is 8.65 on the photograph, 8.65 on the photograph. Now what they are asking is that you are supposed to determine the capital H. Now see, this is the camera, this is the height, and this is the datum. You are supposed to determine the capital H, right? This you have to determine. After determination of that capital H, what he is asking is that suppose the height changes, right? If this small h, in spite of 500, if you take it as 800, then what will be the scale? So in a single problem they have asked two separate sections. One is you are supposed to find out capital H for the elevation of 500 meter. When the small h is 500, what will be the capital H? And as you get that capital H, by using that capital H, you are supposed to determine the scale by taking small h as 800 meter. So we'll solve that problem. You can understand as we go further. Now if you take required formula, what will be the required formula? We know the scale formula. They have asked scale. What is scale? Scale is, see, map distance divided by ground distance. That is nothing but equal to f divided by capital H minus small h. So you are supposed to determine the capital H. So I have taken that. See, this map distance I am going to compare with the map distance divided by ground distance, that equals to f divided by capital H minus small h. So capital H is, I don't know the capital H, so I'll be keeping that as it is h. Now I'll cross multiply the things. So I'll bring that h minus 500 to this side. Then it is going to be, see here, h minus 500, that equals to 20 into this 2000 is going to this side, 20 into 2000 divided by, this is going to come down, that is 8.65. now altogether it is h minus 500 is equal to 4624. now this h is equal to, now this 500 is going to come this side, that is 4624 plus 500, it is going to be 5124 meters. Now this capital H is 5124 meters. Step number 2, where you are going to use that 5124 and you are going to determine the scale when small h is 800 meters. I will take that formula. Yes, 800 is equal to f divided by capital H minus small h, right? So all things are given here. This f is 20 centimeter focal length, capital H is 5124 minus small h is 800. Now scale is 1 centimeter divided by 216.2 meters, that is 1 centimeter on the photograph is equal to 216.2 meters on the ground. Now this is the scale. So they don't ask representative factor, so we are not going to find that. If you want, you can find that representative factor also. Now this is the problem number 4. First I'll read this problem and then we'll decide what we are going to do with this. A section line AB appears to be 10.16 centimeter on a photograph for which a focal length is 16 centimeter. The corresponding line measures 2.5 centimeter on a map which is to a scale of 1:50,000. The terrain has an average elevation of 200 meter above mean sea level. Calculate the flying altitude of an aircraft above mean sea level when the photograph was taken. Now two things are there that you have to carefully understand. Now if you read this problem, what that last sentence says is that you have to calculate the altitude of aircraft above mean sea level. Means you are going to supposed to determine the capital H. Now it will be very easy. See, just you have to understand the problem. They have taken a photograph and they have got the details. What that detail is, see, now they have taken two different scales they have given, right? So that is one photo scale they have given, along with that they have given a map scale. Say map scale is 1:50,000, right? And photo scale, if you take, we can take it as 1:n. Then by cross comparing those things, then we can easily determine the data, right? So see, I'll read the things that what that says is that the section line AB appears to be 10.16 on a photograph. Means this is the distance what you got on the photograph, and along with focal length is also given. Then also they have said that the lines corresponding line measure it as 2.54 on the map. So two different things they have given. One, the whatever line on the ground is there, the same line measures on a photograph, that is 10.16, and the same line measures on a map, that is 2.54. so here you are having the comparison of map and a photograph, right? So the required relation is, right, I can say that required relation. Now here I have written that required relation, that is photo scale divided by map scale is equal to photo distance divided by map distance. Now see, photo distance we are having, that is 10.16. also we are having map distance, that is 2.54. both the things are here. Photo distance is this and map distance is this, right? Only thing is that you should get the photo scale. Map scale is given, right? Map scale is 1:50,000. If you compare these things, so you can get the photo scale there. Photo scale is not given, right? So you can see that map scale is equal to 1:50,000 in step 1, and photo scale will keep 1/n, that is 1:n. that how we represent the scale. So we keep it as 1/n, small n, right? So we don't know that photo scale, so we keep as it is. So that is, see that 1 by small n divided by 1/50,000, that is photo scale divided by map scale is equal to photo distance 10.16 divided by map distance, that is 2.54. Now this 1/n divided by 1/50,000, that equals to 10.16 divided by 2.54. We are going to compare these things to get the 1/n. Now here you can see 1/n is equal to 10.16 divided by 2.54 into that whatever denominator 1/50,000 is there, that we are going to bring this side. So it is going to be 1 divided by 50,000, that we are multiplying to the map distance divided by photo distance divided by map distance. So it is going to be 1/n is equal to 1/12,500. Now this is the photo scale, right? This is the photo scale that was required, so we got that photo scale, that is 1/n is equal to 1 divided by 12,500. Now in step 2 we are going to use that photo scale to determine the height of an aircraft above the mean sea level. Now here you can see that I'll show you step number 2. Yes, 200 is the elevation of that ground, that equals to we know the regular formula, S is equal to F divided by capital H minus small h, but this can be shown like 1:n, as I said previously also, that is 1:n is equal to F divided by H minus H. So it is 1:n is 1/12,500 is equal to 16 divided by 100, as this is the representative factor, right? Scale can be represented in other way also, that is representative factor. So it is 1 divided by 12,500, that equals to 16 by 100 divided by H minus 200. Now that you can bring this here, this side, and you can take this side. So it is going to be H minus 200, that equals to 16 divided by 100 into 12,500. Now this H minus 200 is equal to, that is 2000. Now H is equal to, capital H is equal to 2000 plus 200, that is going to be 2200, that is 2200 meters. Now this is the required thing that what you want, right? So this is very simple problem. Just what you have to keep your cool and you have to read the problem, then bifurcate the things what you are going to do, and then use your formulas to get the required result. Now few more problems are there that I'm going to give in the next video, because lengthening the video is not a good thing. Means no, if I'm having a video of 1 hour, then it will be difficult for you guys to because you don't see, people usually don't have the patience to listen it for 1 hour or something like that. So I am trying to reduce my timing so that you'll feel it easy to just go with that shorter videos and to understand the problem. So I'll be having few more problems in upcoming videos. Stay tuned. This is Professor Balasaheb Jamadar. Thank you.